Now we get to talking about ions, and in order for us to learn about ions, we need to understand valence electrons. Valence electrons are those electrons in the highest occupied energy level of an element's atom. So, in other words, the outermost energy level. So if we have an atom here is a nucleus, we have some electrons here, and electrons here. The very last energy level, highest occupied energy level, would be the valence electrons. These valence electrons are what's involved in chemistry. Now, to find the number of valence electrons in an atom of a representative element, remember, we're just looking at rep now, as opposed to transition, we're going to look at the group number. So the group number. The transition follow their own little rules. It's a little different. These metals here. So we're not going to look at those now. We're looking at the representation, the representative ones. So valence electrons would be the number of group, or the group number, right here. Group 1A has one valence electron, one outside electron. Group 2 has 2 electrons in the outermost shell. Group 3 has 3 electrons in the outermost shell. Group 4, 4 electrons in the outermost shell. 5 valence electrons. 6 valence electrons. 7 valence electrons. And 8 valence electrons, except helium, of course, only has 2 valence electrons because it only has 2 electrons anyway. Another way we can look at it might be in Roman numerals. So 1, 2, 3, 4, 5, 6, 7, 8, except helium. So we should know that should just be ingrained in your brain. And these transition a little different. They have usually 2 to 3, 1, 2 to 3 valence electrons, these metals. So we should get to the point looking at the chart, we know how many valence electrons it is, and that's just by the group they're in. The octet rule. So when forming compounds, atoms tend to achieve the electron configuration of a noble gas. So remember, the noble gas has 8 valence electrons, except for helium, which has 2. But even in that case, the atoms will tend to achieve the electron configuration of a noble gas of 8 electrons or 2 electrons, a filled energy level. So that's the king, the key, or the king, noble king. 8 valence electrons, noble gas, or 2 valence electrons, noble gas, helium. And again, to reiterate, nobles have 8 electrons. So this is chemistry. This is what they're all trying to do. That's the basis of chemistry. They're just trying to get 8 electrons. They're trying to be like noble. They're trying to get a filled valence shell. Their outer electrons are just trying to be filled, and they're going to just react with things to get a filled shell. That's why things will react with things, basically, generally, just so they can get those 8 electrons or 2 electrons, a filled valence shell. Now, in order to achieve this 8 state, or valence state of 8 electrons or 2 electrons, they will either be involved with sharing the electrons to have 8 or 2, or they will lose or gain electrons. So we're just going to talk about when they lose or gain electrons, and that would be when they form ions. So they will lose or gain electrons. Next chapter we'll talk about where they share electrons to have that noble configuration of 8 or 2. So atoms will either lose or gain electrons to have their highest energy levels filled. And they become a charged group of atoms. So they will either be, an atom will be plus or an atom will be negative. And we've talked a little bit about cations and anions. Now, cation. Remember, a cation is a positive ion. They will lose valence electrons to have their outer energy level and become more stable. A positive charged ion is formed. So metals will tend to form cations. So metals, this way over, those will tend to lose electrons and become positive till their valence shell is filled. People think, well, if you lose something, shouldn't you be negative? And if you gain something, shouldn't you be positive? No, it's the opposite with atoms, because you're losing, what you lose or gain are negative electrons. So if you're losing a negative, you become positive. Such as, let's say, here you are, or someone, they have nails or something in their head. And if you tend to lose those nails, it'll be better. Okay, you'll be positive if you lose these nails. So if this person lost a nail in their head, they're more positive. They're one more positive. If they lost two, they'd be two positive. If they lost three nails, they'd be three positive. As opposed, if this person got an extra nail, it'd be extra negative, two extra negative. Now cations, they'll lose an electron because they want to get their outside energy level filled. So if we look at an atom here, such as lithium, lithium has three protons, 4 neutrons, 2 electrons, and then it has 1 electron. They want 8. So this one says, well, my gosh, I have to get 7 more to be like neon. To be neon here, I have to gain 7. So lithium says, I need to get 7 more electrons to be like neon? Well, no, I don't think so. I'm just going to lose this 1 electron. If I lose this 1 electron, hey, look at that. Isn't that neat? Now I have my outer energy level is filled at 2 electrons. It's filled. I'm happy. So now I'm like helium. Lithium is like helium now, 2 electrons in its outer energy level. It's filled, he's happy. But look, he has 3 protons and 2 electrons. So lithium will have an overall positive charge because it's lost an electron in order to have a filled valence electron shell. Let's look at aluminium. Aluminum has 3 valence electrons, and it would need 1, 2, 3, 4, 5 in order to be like argon. But if it lost the 3 valence electrons, if it lost this one, this one, this one, it could be like neon. So here's aluminum, 2 electrons, 8 electrons, 3 electrons. If it wants, it needs to get 5 more to be like argon. Or what it can do, it's easier just to lose these 3. It tends to lose these 3. Hey, look at that. This last energy electron is now filled. Aluminum is happy. But the charge is different. It has 13 protons and 10 electrons. So aluminum will have a excess 3+ charge because it lost those 3 negative electrons. Okay, what about anions? Now, anions will gain electrons to have a filled outer energy level and to become more stable. And if you gain something negative, you're going to become more negative. Okay, if you gain a nail in your head, you'll become more negative. It's kind of negative. Some people don't think so, though. Some people like to put things in their head like nails and screws. There was a lizard guy with, you can look him up on the web, but he's got nails in his head. But anyway, let's look at oxygen here. Oxygen has 6 valence electrons. It only needs 2 more to become like neon. Only needs 2 more to become like his hero neon. So the ion will give him 2 more electrons. He's happy with, or she, it's happy with 8 electrons on the outer valence electron. It's filled at a outer valence energy level. So oxygen with those 2 extra electrons will have a charge of 2 minus. Okay, so now let's look at chlorine. Chlorine has 17 valence electrons, 17 total electrons, 17 protons, 18 neutrons. There's 2 electrons here, 8 electrons, and then 7 electrons there. It only needs 1 more electron. It'll be like his hero argon. We can give it another electron, make it happy. So remember, they're very electronegative, group 7, because they just want 1 more electron. They're going to rip that from anyone they can. So chlorine will have an extra negative charge. Now another way we can even visualize this is with the off-bow. It doesn't even matter what we form. If we have lithium here, lithium has that 1 outside energy level. It's in group 3. It has 1 valence electron. We get rid of it, it's happy. It loses 1. Its outside energy level, 1s, is filled. It's happy. If we have 1, 2, 3, 4, 5, 6, 7, that would be total 7 electrons, and we can even just look at, without counting, we can look at the last energy level, the 2s and the 2p. The 2s and the 2p are the last energy level for this atom. So we have to put in the 2s and the 2p for their final electron level. And we can see this has 5 outside energy level electrons, so that must be in group 5, the second energy level, so that's nitrogen. Now if it has 5 valence electrons, it would be easier for it would tend to attract 3 more as opposed to give up 5. So if it would get 3 more, we would have nitrogen 3 minus because it got the extra 3 electrons there. And it now has a filled valence shell with 8. 1, 2, 3, 4, 5, 6, 7, 8. Now let's look at this atom. It has, we can count the total, but we can also look and see, without even counting the total electrons, we can see that in the 3rd energy level it has 3 valence electrons. With 3 valence electrons in its 3rd energy level, we can see that's aluminum again. Now what does aluminum want to do? It has 3 electrons. Would it tend to lose those electrons or gain 5? For it to be happy, it would have to gain 5. It would be much easier for aluminum to lose these 3. Now its outside energy level is filled, but if it lost 3, it's going to be 3 plus. And that is a happy camper there. So let's look at this last one here. If we have this setup, how many in the outside energy level? Well, the outside energy level, even though it filled up 4s, then 3d, then went to 4p, the outside energy level is the 4s, 4p. So we're going to look at these. How many electrons are in these sp? We have 1, 2, 3, 4, 5, 6. 6 electrons in the 4s energy level. So that would be selenium. In the 4th energy level. So selenium, now would selenium want to lose 1, 2, 3, 4, 5, 6 electrons, or would it be easier just to gain 2 more? Exactly. It would be easier to gain 2 more. So 1, 2, selenium with the extra 2 electrons would have a charge, a net charge of 2 minus. Selenium is stable with a filled 4th energy level. It's happy. It's just like its hero, Krypton.